Good afternoon, ladies and gentlemen. Today, my presentation is a model explaining RNA level fluctuation based on RNA activity demands and RNA age. Introduction. Facing environmental stimuli, a cell will have response of gene expression to adapt to environment. Under stable environmental stimuli, RNA level usually fluctuates, but the mechanism is difficult to explain. Some important factors had never been studied, such as the demand of RNA activity and RNA age. Environmental stimuli could be considered as the demand of RNA activity. Too high or too low RNA activity may be harmful to the cell, so regulation of RNA level to meet the demand is necessary to maintain cellular healthy. But the relationship of the demand of RNA activity and RNA level fluctuation is unclear. As for RNA age, RNA produced at different times may coexist in the cell, and they may have different RNA activities. So the same level of RNA with different RNA age may have different RNA activity. But the relationship between RNA age and RNA level fluctuation remain unknown. So we build a model involve the demand of RNA activity and RNA age to study the mechanism of RNA level fluctuations. We have built a model, RNA age and the demand of RNA activity, transcription, degradation were involved in this model. We extend this model to two-unit model to study the relationship between RNA level fluctuation and protein level fluctuations. We set parameter values according to biological knowledge and reference. We found some experiment data in published paper to validate our model. We use C++ language to write the program and use R language to draw the features. The results show that stable stimuli may result in cycling RNA level fluctuation. This is the demand of RNA level activity. If the amount of RNA activity in the cell was lower than the demand, transcription stops. If the amount of RNA activity was higher than the demand, transcription stops and degradation continues. So leading to cycling RNA level fluctuations. RNA age might affect the shape of the curves, making cycling longer or shorter. When environmental stimuli change, RNA level and RNA activity amount may follow these changes. The results show that different levels of stimuli may change the cycling length and vibration amplitude of the RNA level fluctuation. That's to say, sampling type was very important. Take an example, if we took a sample at this time point, the results show that gene expression was upregulated. But if we took the sample at this time point, the results show that gene expression was down-regulated. This is another example of the effect of sampling time. The black line was the correct data. And if we took the sample every 8 time units, then we may got the result of a stable line. And if we took the sample every 9 time unit, we may get this result. The green one was the result of a sampling interval of 10 time units. So different sample time design might lead to different results. Stable RNA level may indicate the total RNA activity could not meet the demand or transcription was out of control. In this case, the total amount of RNA activity was higher than the demand during all the experiment period. That's to say, the transcription was out of control. In this case, the total amount of RNA activity was too low to reach the demand. In this case, the demand was too high. We found some data in the published paper, and the simulation results showed that the fitting index was well. So we think that this data might support our model. Using our model to analyze time series gene expression data, we could estimate some parameters such as the demand of RNA activity, transcription rate, degradation rate, and lifespan of RNA. There were some times of relationship between RNA level fluctuation and protein level fluctuation. Under stable stimuli, RNA level and protein level could be both cycling. If RNA level was cycling, protein level could be stable. RNA level and protein level could be both stable. Therefore, it is difficult to use RNA level to directly calculate protein level. But the ratio of protein translation rate to RNA transcription rate was in the limit range. So we may use this ratio to estimate protein level or protein translation rate. Discussion. How to measure the demand of RNA activity is one of the questions of our research. If we had enough experiment data, we may estimate the demand of RNA activity by solving the regression equations. How to measure RNA age distribution has been never studied yet. RNA could be labeled, so we think if maybe we could put RNA in the label medium at different times, and at the end of the experiment, we extract the label RNA and measure the demands. Then we may measure RNA age distribution by calculating the difference of RNA amounts in different groups. Some RNA could enter into cell from outside, and some cell may release RNA. In the model, we regard input RNA as transcription and regard export RNA as degradation. In the future study, we may isolate input RNA from transcription and isolate export RNA from degradation. We think the basic model could be suitable to other biological molecules. So we may contrast two unit model, model tray and model web, to study the relationship of different biomolecules. Conclusion. We use the demand of RNA activity and RNA age to build a model to study the mechanism of RNA level fluctuation and get some useful and interesting results. But this model needs further experiment support and application study. Thank you for your attention.